So hello, welcome to our videos that we're going to experience this entire year with. Obviously this is me, Mr. Swenson, and I thought I'd start off just by going a quick couple things that we're going to need before we start the notes for level 1.1. Now, all of the chapters in the book I'm going to refer to as levels, kind of like a video game, just to show how each thing that we're going to learn this year is going to progress, and we're going to reference things over and over again like a video game. So, in order to start, I've got my pens. I'm going to be using a couple different colors. I got different Sharpies, and the other thing that we're going to utilize is our TI Inspires. Now, I have a CX, but on the syllabus, if you look for it, I have the recommended version. And over the course of all of these videos, I'm going to show you guys exactly how we want to use them. So, just as a brief overview of what we're going to be covering in this level, we're going to be talking about the distance and midpoint formula, graphs of equations and two variables. These two are very short sections. The third is basically everything you learned in Algebra 1 about lines we're going to talk about, and then to wrap up this unit, we're going to be talking about circles. Down below, and this is going to happen for every chapter or level, is I'm going to list out all of the concepts that you guys need to know by the end to feel like you have mastered this level. And then you're ready for the boss test, or the boss battle, the boss test. You know what we're going to do. So let's start with the new material. So level 1.1, distance and midpoint formulas. So this is a big overview of the topics that you guys should probably know that you're bringing to me from Algebra 1, college algebra. So let's first start off with the rectangular or Cartesian coordinate system. That is the official fancy name we call the XY coordinate plane. This is a two-dimensional object. What lives on there are our coordinates, which are ordered pairs. And that can be listed in our parentheses, and we're just going to call any point x1, y1, where the first, just like in the alphabet, the first thing that comes up is the x variable, the second is our y variable. And if I wanted to pick any value, that coordinate lies, we say it lies on the rectangular coordinate system or the xy coordinate plane, and we call any ordered pair a point with the values that it has. Last up, we should all remember the quadrants. We start in the upper right-hand corner and we go counterclockwise. The first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. We're going to see these throughout the years and throughout this entire school year, and this is going to be really important. All right, next up, distance formula. So I gave this to you guys. I hope you have this memorized. Oftentimes, we don't write it as the distance between 2 points, but this is the official notation. Oftentimes, we just write it as d equals the square root of the difference in the x's, which I'm going to use a fancy way. This triangle means, it's a Greek letter, means delta, and we use delta for difference. And the nice thing about the distance formula, if you have the difference in the x's squared, it doesn't matter the order in which you pick what points. Plus the difference in the y's squared, and then you take the square root, we get the distance between those 2 points. So let's try an example. Find the distance d between the points 1, 3 and 5, 6. So what I like to do is I like to draw the graph first. It's important that we get in the habit of labeling, and let's label that right, the x and the y coordinates. So we have 1, 3. So 1, 1, 2, 3. There's my point 1. And the second point is 5, 6. So 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I want to know what's the distance between these two. So we plug it into the distance formula. Distance equals the difference in the x's, so I'm going to do 5 minus 1 squared plus 6 minus 3 squared. So 5 minus 1 is 4, so this is 4 squared plus 3 squared, square root. Now, we should know our perfect squares. 4 squared is 16, 3 squared is 9, which gives us the square root of 25. Square root of 25 is 5. This should be pretty simple, pretty quick. So our answer is the distance between those 2 points is 5. Let's try another one. Find the distance d between the points negative 4, 5, and 3, 2. So I suggest you don't have to do it, but we could, just to get practice graphing, is plotting these points, and then 3, 1, 2, 3, 1, 2. This, if I'm close enough, is the distance we're looking for. So let's go to the distance formula. D equals the square root 3 minus a negative 4 squared plus 2 minus 5. 2 minus 5 squared. Could you do reverse order? Yes, and you'll get the exact same thing. So if I subtract a negative, change both signs. So that leaves me with square root of 7 squared plus 2 minus 5 is negative 3 squared. So this is the square root of 49 plus 9, which is the square root of 58. Now, since we're seniors, we should know we could try and simplify this. But quickly looking at this, 58 is 29 times 2. 29 and 2 are both primes, so we can't simplify it. So we can leave our answer as d equals the square root of 58. Now currently, when we work on all of these problems, I want you to leave these as radicals. I do not want any fractions or decimals for this first part. We're going to work on simplifying square roots if we have to. All right, moving on to the next page. All right, we have one more distance problem, and then we're going to move on to the midpoint formula, and we're done with the first lesson. So, consider the 3 points A, B, and C. Plot each point, find the distance between each side of the triangle, and verify that it's a right triangle, and find the area. This is asking a bunch of stuff from us, and we all know how to do it. So let's see. I'm going to plot the 3 points just to see what it looks like. So negative 2, 1, 2, 3. So 1, 2, 1, 3. That's A, that's B, and I'm going to label my points. And then C is 3, 1. So I have a triangle that looks like this. That's my scale. Now, to me, based off my drawing, that doesn't look like a right triangle. But I can quickly do this. I can find the distance between A and B and C, and A and C. So the distance between AB, and this is where we get to the labeling, so I'm just going to do a subscript of AB, is the square root of the difference in the x's, 2 minus a negative 2 squared, so that's 4 squared. 3 minus 1 is 2 squared, so that is the square root of 20. 16 plus 4. So that's the distance for AB, and I'm also going to put that in my picture. That's the square root of 20. The distance from B and C is the square root of B and C, so I'm going to do 3 minus 2, which is 1 squared, 1 minus 3 squared, which is negative 2 squared. So the distance between BC is, well, 1 plus 4 is 5. And the distance between A and C is the square root of 3 minus a negative 2, which is 5, squared, 1 minus 1 squared, which is 0, So this leaves me with the square root of 25, which is 5. So how do you tell if something is a right triangle? Well, what do you guys remember about something being a right triangle? It fits the Pythagorean theorem. Yes, that comes back. It always comes back. We're going to see that near the end of this year when we start talking about trig. A squared plus b squared equals c squared. So, as long as c squared is our longest side, we're going to say 25, which is 5 squared, equals root 5 squared plus root 20 squared, which is really saying 20 plus 5 equals 25, which is true, which means it's a right triangle, which is what we verified. So far we've plotted each point, found the distance of each side, verified that it's a right triangle, find the area. Last thing that you should know, this is all great for practice for the ACT too, if you're going to take it again. Area for a triangle is 1/2 base times the height. Base, root 5, height is root 20. So this is 1/2 root 20 times root 5. Now how do you multiply square roots? Well, you can multiply the insides. So this is 1/2, 20 times 5. 20 times 5, so that's, if I wanted to, I can count by 20s. 20, 40, 60, 80, 100. Square root of 100 is 10. Half of 10 is 5. And if we want to just be super exact, we can write units squared, because that's our formula. That takes us through the distance formula and most of the problems that you're going to see on the homework assignment in class. Last up, midpoint formula. Midpoint formula is the average of two things. So we take the average of the x's and the average of the y's. So we add the two x's up, divide by 2, add the two y's up, divide by 2. We want to look at a problem. Find the midpoint of the line segment from -5, 5 and 3, 1. So again, just to hammer home the point of how do we plot points, you'd be amazed at how many people struggle with plotting points. -5, 2, 3, 4, 5, 5. So that's my first point. My second point's at 3, 1. 1, 2, 3, up 1. And I want to know where the midpoint is between these 2 points. Well, we can kind of guesstimate that it's going to be a negative number-ish. So the midpoint is an ordered pair. That's the key thing. You notice these parentheses up here? It's an ordered pair, so we always want to have this in parentheses. It's super important that if we're giving a point as an answer, that our answer is in parentheses. So let's average these two. -5 plus 3. -5 plus 3 over 2, and 5 plus 1 over 2. -5 plus 3 is -2. -2 over 2, comma, 6 over 2. Which, oh my gosh, fractions, they're scary. -1, 3. Which is basically, if we graphed it right, what it looks like. So that is the end of our first video. I'm trying to keep them short for you guys. In class, you guys are going to work on these problems, and then you're going to be experts at the distance and midpoint formula. All right, moving on to the next level.